All right, so let's solve the 10th day of AoC in HolyC. There we go. Day 10, syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies syntax error in navigation subsystem online, all of them. All right. All of them? The damage is worse than you thought. You bring up a copy of the navigation subsystem, your puzzle input. The navigation subsystem syntax is made of several lines containing chunks. There are one or more chunks on each line, and chunks contain 0 or more other chunks. Adjacent chunks are not separated by any delimiter. So if one chunk stops at next chunk, if any can immediately start, every chunk must open and close with one of the 4 legal pairs of matching characters. So I can see parentheses here. If chunk opens with this, it must close with... Are you gonna hit me with like a school puzzle of matching parentheses or something like... Wait, what? Okay, if a chunk opens with this, it must close with that. If a chunk opens with this, it must close... okay. So is a legal chunk that contains no other chunks as is more complex, but that... Alright, some lines are incomplete, but other are corrupted. Find and discard the corrupted lines first. A corrupted line is the one where chunk closes with the wrong character. That is where the characters it opens and closes did not form one of the 4 legal pairs listed above. Example of corrupted chunks include... okay, cool. Such chunks can appear anywhere within the line, and its presence causes the whole line to be considered corrupted. For example, consider the following navigation subsystem. Some of the lines aren't corrupted, just incomplete. You can ignore these lines for now. The remaining 5 lines are corrupted, so expected... Okay. Stop at the first incorrect closing characters on each corrupted line. Did you know that Syntax Checker actually have contests to see who can get the high score for syntax error in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. So, okay. In the above example, an illegal was found twice, 2, 3, and illegal was found, 57 was found, blah, 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 so you add them up. Find first illegal character in each corrupted line of the navigation subsystem. What is the total score of error score for those errors? Okay, cool. Let's go ahead and implement that. So for those who don't know, it's like a classical matching parentheses problem in computer science. So people probably study that in schools. Right, so and essentially when you have the same kinds of parentheses, you just use a counter. Every time you have an opening parenthesis, you increment the counter. Every time you have a closing one, you decrement the counter. When you have different kinds of parentheses, so it gets upgraded to the stack. So this is actually a pretty like classical example when people start talking about stacks, right? Because if you have opening parent, you put it on the stack. And then when you have a closing one, you look at the top of the stack and see if they match, right? And see if they match. And then if they match, you basically pop it out. If they don't match, you report an error or something like that. So that's basically what we have in here. So I suppose the part 2, so they say that ignore incomplete lines, right? So they say ignore incomplete lines. I can try to predict that the second part is going to be completing an incomplete lines. Right, and some sort of like a proof of solution, right? Okay, let's go ahead and implement that. Why not? I mean, why not? So let's run AoC in freaking HolyC. All right. Boom. So let me see. It's going to be a new day, a brand new day. There we go. So this is a brand new day. Though I want to actually like close the virtual machine and maybe mount everything. So probably I should probably make a system that creates a new day outside of the virtual machine, because I do a lot of stuff outside of the virtual machine to prepare the new day, like downloading the input and downloading the samples and stuff like that. So maybe it makes sense to do that outside, if you know what I'm talking about. Right, so I'm going to do that off screen at some point. So AoC, the 10th day, and let's grab the sample. So this is our sample. This is our sample. ed sample txt. Right, so I'm going to insert that thing, and I'm going to just copy paste this entire stuff. This is not what I wanted. Okay. If I cut this entire thing, no such file, ed, insert, do that, save, boom, cool. And if I take a look at the sample, there we go. So how big is the actual puzzle input? That's pretty big, not gonna lie. Okay, so ed input txt, so I'm gonna go in here, I'm gonna select everything, copy paste it in here, and save everything like that. So did I do everything correctly? It seems pretty good. Compression, I really apologize for the compression, but it is what it is. Right, so I can't increase my bit rate. And to be fair, when you're dealing with text, increasing bitrate does not really improve the quality, because there's like a lot of small little characters anyway. It's just like you need a really high bitrate to combat that, I think. All right, so let me see. So luckily it is super easy for us to iterate through all of the lines, I feel like. Right, because we don't even need to save them right now. So we just iterate through them and that's it. Okay, so let's go. We're gonna have something like line. While SV size is greater than 1, right, it is greater than 1, what am I doing in here? And it's going to be the following thing, SV chop. Do you want to chop line? Actually, oh, this one is rather interesting, right? So because we need to chop not really the word, we need to chop by the delimiter. So we have to like follow until we encounter a particular character. So I think the time has come for me to implement a very cool function that I use all the time outside of HolyC, and this one is going to be chop by delimiter, right? So it's going to accept the string view, and it's also going to accept a delimiter. So Nzeal, thank you so much for Twitch prompt celebration, thank you, and welcome to our epic AoC in HolyC club. All right. Okay. So this is the delimiter, though we also need to return like into like where it's gonna output this kind of stuff. So probably we need to have something like out in here. There we go. Cool. So U0, let's go ahead and implement that stuff. So I'm probably gonna start with setting the begin of the output to the begin of SV, right? So this is that, and then we need to start with tracking of this thing. So we have I, and initially I starts at 0, and while I is less than SV size, right, plus I. This one is interesting. We might as well use while I is less than SV size and SV begin I not equal to the delimiter, right? We're going to be just incrementing that I, and there we go. So that's what we got. That's what we got. And essentially, when I stopped, I becomes the new size of the output, right? So it becomes the size, which brings us to a very interesting point. Oof. I have no idea what is it doing in here, but let me quickly get rid of this thing. So out begin has to be equal to SV begin. So we have that. But furthermore, now we need to chop this stuff out of the input, right? So we need to chop stuff out of the input. And the question is very interesting. It's just like depends. If I was less than SV size, that means we're gonna do it like this. SV begin is going to be incremented by I, but +1, because in this particular case, we want to skip the delimiter, right? We want to skip the delimiter, and here the size is also going to be decremented by I +1, right? If I is greater or equal than the size, that means there was no delimiter at the end. And this entire thing is going to be basically +I, and the size is going to be -I, which will result in empty string. That's basically what it will result. It will result in empty string. So we have to take all of that into account. So we have a chop by delimiter now, so we should be able to use that. After I solve this problem, I'm going to actually copy that into the module commons that I have it in here. So basically the code that is shared across several things. So, and what's interesting, okay, so that's fine. That is fine. Did I miss anything? Let me double check. Okay, there is something sus in here. I think this is the sus that we have in here. Okay, so let me see. We're gonna do the following thing: sv chop by delimiter, and we take sv. Then the delimiter is gonna be the new line, right? So this is the new line delimiter, and the output is gonna be the line. Okay, cool. So I just realized that we can use the return of this function as an indication whether it was like it had the delimiter or didn't have a delimiter, but I mean, it's not really that important here. Okay, so we have a line, and how can I print this entire thing? What is the easiest way to print it? Because it's not null terminated, right? This line is not null terminated, so you can't just do that. So I think I'm gonna do the following thing. I'm gonna do u0 print sv, right? And it's gonna accept the sv and it's gonna just print it, right? And the way it's gonna print it, you know, character by character, right? And I think the cool thing with TempleOS is that TempleOS doesn't have any context switch, right? So, and I suppose printing character by character is not as slow as in operating systems like Windows and Linux, where there's to print something you have to go into the operating system and back all the time. Here you don't have to go anywhere, so you can just like print character by character directly, and that might be faster. At least maybe there is no penalty for doing that, right? So it's not necessarily faster, but at least maybe there is no penalty. That's what I'm trying to say. So we're gonna do it like this. Who knows? I know nothing about TempleOS, to be fair. So, and in here we're gonna do something like this. So this is gonna be C, and yeah, SV begin I. Something like this. I wonder, does HolyC support something like const? It doesn't have const. Okay, so Terry didn't buy into the const correctness bullshit. That's actually pretty cool. That is actually pretty cool. Okay, so we chop this entire thing, and I suppose now I can try to print this entire stuff. I'm just gonna pass this stuff in here, and unfortunately it doesn't have like a new line. And there we go. So if I try to run this entire thing, it does not even compile. So let's take a look at the line 13. What's in the line 13? I something something. Ah, of course. Freaking of course. Terry didn't buy into const correctness bullshit, but he didn't fix the arrow operator mistake in C. Okay, so we have another one. So this is going to be 15. So what do we have in here? Out, begin, SV begin, so I forgot to put a semicolon in here. Okay, so it is fine. Okay, so there's another one, 18. Again, so I keep forgetting about this stuff. It's getting worse and worse. I really like how it's getting worse. Okay, so yikes, yikes. Okay, so it's a 41. And in here, right, we do print SV, and I put an extra V in here. Finally. Okay, so that's pretty cool. I think we read everything in here, which is super nice. So I wonder if we can. Is it possible to like read the whole file? I think it is. So this is the cool thing about TempleOS. You can use the same functions in how to say that? Well, it's not going to help you. You can use the same function, so that means I can try to read the file from here, right? Read the file sample txt, and maybe that will sort of cut the file, but I just realized that reading the file does not null terminate it, so I don't think it's going to be the case. So you can't really do this kind of thing, unfortunately. Right, you can't really do that, yeah, so it's just not going to work properly. So I just want to compare the output side by side. The cool thing is that I can include main HC, right? I can include main HC, and that will execute it, and that didn't work for whatever reason. So okay, TempleOS is not as cool as I thought, but yeah, so this is one, and I just want to take a look at the sample. I think it worked correctly, right? I just compared the last line, so the last line was more or less correct. Okay, cool. So we need to now just do a very simple thing. We need to find the corrupted lines, right? So let's go ahead and do this thing. Corrupted score. We're gonna accept the line, right? And this entire thing is going to return the corrupted score if the line is corrupted, and -1 if there is no any corrupted score, right? So yeah, essentially, I suppose. If the line is incomplete, we'll probably have to, yeah, that's kind of interesting, so we'll see. As already said, we'll need to maintain some sort of a stack. The question is, what's going to be the size of the stack? The size of the stack is going to be equal to the size of the line. The size of the line is around 100, right? So I suppose what I'm going to do in here is just like allocate maybe twice of as that, maybe even more, right? So this is going to be stack capacity, right? And let's just allocate straight up like 1,000 of those things, right? Thousands of those things. And the stack itself is going to be essentially just a stack of characters, right? So stack capacity, and here we're going to have something like I64 stack CNT, right? Initially it is 0. Maybe not. So, and do I want to have like things that that push into the stack and pop from the stack? Because pushing in the stack is essentially going to be stack CNT++. You push a value into the stack, and popping from the stack is essentially stack CNT, like this. So you pop from the stack, and so this is push into the stack. Then this is the pop from the stack. The size is obviously just stack counter. At the top is stack CNT -1. And yeah, so each of these operations that is just basically a single line, so I don't think it makes sense for me to like create functions for that. So that should be fine. Okay. Did I just remove corrupted score? I think I just removed corrupted score. Okay, so I64 corrupted score. I swear to God, TempleOS is gonna be death of me, like seriously. Because like sometimes it just does really weird shit, and I can't get used to that. I just can't get used to that. 0 less than line size ++I, and there we go. There we go. So, and here's an interesting thing. We need to be able to distinguish between open parentheses and close parentheses, right? So we probably need things like is open and is close. Let me quickly do that. So boolean is open, U8, X, right? And how many of those things do we have in here? So return X, let me see. There's 4 of them. Okay. So can I do something like this, and this, and just find that thing within that string? Does like HolyC even have anything for that? There's no strchr whatsoever, which is kind of sus, but okay. We can though iterate through this entire thing. So, but that will essentially require to do the following thing. You know what? It's just like easier to like hardcode this entire shit. Okay. Right. So let's not try to be smart asses in any way. So this is open, or this, or this, or this. Totally fine. Right. There's no reason to be a smart ass about it. So we'll just like make a thing. Okay, boolean is close. Right. Totally works. U8x. All right, so we're gonna do something like this. Might as well copy paste this thing, so it will be easier for me to modify this stuff. All right, so this is gonna be like that. And let me see. So this is gonna be that, 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 and that. Okay. Oh shit. I also want to be able to check if the parentheses are matching or something like that. Right. That's fine. Okay, so if a particular thing is open, right? So is open line begin I, so this entire thing is open. We need to push that into the stack. So that's essentially what we're doing. Stack cnt++, and I'm just adding that thing in there. So this is gonna be line begin, and I'm not, it doesn't fit in there. God damn it. So let's actually have something like this. I8x. Oh boy, but it's not particularly great, so we have to do something like this. Equal line. I have to take the pointer to that. HolyC is so freaking dense. It's just like, it makes it so difficult. Just like the challenge is just like using this thing. I hate it. I hate it a lot. Okay, so this thing is open, right? This thing is open, and we just assign it in here. So for those who are probably wondering why I'm using the pointer in here is because, like, if you do that, the HolyC complains that your thing is going to be 64-bit actually, because it cannot just put this thing in a register, right? So it has to use a bigger register than the type of this thing. So, and I just don't want to listen to its complaints. Which I'm not really sure, maybe it's fine, but I just like don't like warnings, and TempleOS is really bitchy about it for whatever reason, right? So it doesn't check the proper types of the pointers, but it screams about you having a type that doesn't fit into the register for whatever fucking reason, which I don't fucking care. Like, it's just like, why? The priorities are completely wrong. Like, why do you have such priorities? I don't know, I don't understand. Like, sure. Anyways, else if is close A, and what we need to do in here, so we probably need to basically see if these things are matching, right? And the last thing I want to do in here, otherwise, I probably need to print some sort of like an unreachable thing, right? So which should never probably happen, but you know, you never know. Unreachable. Right, so if it's a close, right, if it's a close, there are two situations when it's close. When you have something on the stack and when you don't have anything on the stack, right? So that's basically the situation, right? If, yeah, if there is something on the stack. Oh, I just got a pretty cool idea. I just got a very cool idea. So essentially we can have a table. We can have a table of these things. Just a second. We can have a table of these things. Right, so we can do something like this. Right, and essentially you try to find, man, I really wish TempleOS had a find operation for the string. Right, I really wish it had something like that, but unfortunately it doesn't have that. Okay, so we can have something like open, and then close. And I think I need to make a small break. So let's actually make a quickly small break. Okay, so I've got a pretty cool idea actually. So what I want from this is open and is close is basically obviously determine whether it's open and close, but I also simultaneously need to determine the kind of the parentheses, that the parenthesis, bracket, curly brace or triangular thingy, right? So I need to determine its openness and the kind simultaneously. So I need some sort of like a single function that does that for me. Right. So I wonder, can I use enumerations in here? But I'm not sure if it's a good idea. Or maybe this is something that we want to learn. So there's no enumeration in here, which is fine, I guess. Right. So we can define something like open. Is going to be 0 and close, which is going to be 1. Right, and the amount of kinds, we have 4 kinds, right? So let's actually do something like kinds CNT, right? So we have 4 kinds in here. So, and the function that I want to define in here is essentially the thing that describes parent, right? So describe parent. So, and it's going to accept U8, and I suppose it's going to just return a number which says whether this thing is open or whether this thing is close, right? So, and on top of that, through the parameter, through the second parameter actually, it's going to return the kind, right? So it's going to be I64, and we're going to say something like kind. So what is interesting in here is that it is super easy to do that if you have the following string, right? So let's actually put all of the parentheses into a single string, like this. So these are the open parentheses, and the closing ones are going to be like this, right? And I think I did everything correctly. So here are the parents, hopefully, parents. Cool. So we also want some sort of index in here. So and basically what we do now, we're gonna just iterate through all of the parents and just find x in those parents. So so might as well actually do something like this. So this is gonna be equal to 0, and while I is less than I suppose it has to be 8, but I really don't like to do this stuff. Okay, so this is going to be 8, and parents I not equal x, we just increment plus plus. Here is the interesting thing. The I contains enough information for us to tell whether the parent is open or close and what is the kind of that parent. So I contains both of these things simultaneously. Right, how can we tell whether it's open? Well, I is less than 4. All of the open parentheses are located before 4, and if you equal 4 and greater than 4, it's closed. Easy. So what's the kind of the parenthesis, right? The kind is going to be determined by numbers like 0, 1, 2, and 3. This one is going to be 0, this one is going to be 2, 3, and 4. Right, so, and essentially we can take I and take a mod of 4. Right, so if it's open this parent, mod 4 is going to be 0. If it's open this parent, it's equal to 4, mod 4 is also going to be 0. If it's this one, it's going to be 1, and if it's this one, it's going to be 1. Right, so the type can be determined by this. So I, just the position of that thing, already have like enough information to tell whether it's closed or open, and what kind of parenthesis it is. So, and we basically extracting that information out of it. And then we can just assign the kind like that. So, and that should be enough, essentially, I think. Right, so we should be also be able to remove this kind of thing. Unfortunately, I'm not sure. So 0 means open, right? 0 means open, and close means 1. So it's kind of like, I really don't like that. Because I like to be explicit, right? I really like to be explicit. So if this thing is true, right, I want to return open, otherwise I want to return close, right? Like I like to be explicit like this. I'm not sure if the ternary operator works in TempleOS. I would assume that not. Maybe Terry doesn't like this kind of stuff, but this function should be enough to describe like literally everything, hopefully. So, and on a stack, we can store only the kinds. So that's what's cool about it. We can store only the kinds. Yeah. So that's basically it. I really like the idea. I can't decide. I'm very indecisive when it comes to this kind of stuff because there's too many options, right? So I really don't like when there's too many options to do like things. And if I'm gonna go with this idea, that means the function name should reflect what's going on. So that means this thing should be called isOpen. Right, so I think it should be called isOpen, right? IsOpen, and then it will return a kind. So, and because of that, it should be probably Boolean. Right. So, and also here we have CMD count. Do we need a CMD count at all? We kind of need kinds CNT just to be able to do this kind of stuff. So kinds CNT. And this one, like, I really don't like, whatever. I should actually calm down. I don't know, sometimes it's just like I get wind up about like stupid shit. So if is open, right, and we also need to have the kind, right, so the kind is going to be somewhere here. So here's the kind, right, and this is another thing. So we can remove this entire thing, and if it's open, what we do, we just like push that onto the stack. So CNT++, and we just put like kind in there. If it's close, so there's two situations when the stack is empty, right? So it's basically you know, equal to 0. And when the stack is not empty, right? When the stack is not empty. So I suppose when the stack is empty, we assume that it's not correct, right? So it's a first illegal character, and we just need to return the amount of points in here, right? So we just need to return the amount of points. So corrupted score. So let's call this line corrupted score. And another thing we're going to have in here is probably char score. I don't want to type corrupted too often. So let me quickly remove this entire thing. So this is going to be char score. U8. So this is going to be X. Right. And in here, what I need to do, I just need to switch upon the X. Right. So, and in here, we're going to do the following thing. It's going to be case. Score. It has to be kind. We have to accept the kind. So, and since kind is the number, we can use an array. So it's I64 char score kind CNT, right? And in here we're gonna have the following thing. So yep. So I think I'm using the same order in here, right? So it's gonna be 3 57 57 1197 right, 1197 and then 25137 25137. Did I do that correct? 25137 1197. Okay, so that should be it, so we don't have to worry about this kind of stuff. Okay, so that's cool. Okay, so if this is incorrect, we can straight up return the char score by using the kind that we just got. Okay, cool. Otherwise, if you have something on the stack, we need to compare it. So we need to do stack CNT -1, and if it's not equal to the kind that we have in here, we also return the char score as well. So it's actually kind of like we can put OR in here, right? We can compress these two things, two conditions, and just put OR in here. Right, and here is going to be just like a regular otherwise, and in a regular otherwise we are going to simply do stack CNT -, right? So that makes sense. And before doing the line score, we should always like reset the stack, set it to 0, and that is it. So yeah. So this is a line score, and for this thing, if we went through the entire thing, the line score is going to be 0, right? So it should be fine. Did I do everything correctly? Holy shit! Right. So this entire thing is really fiddly, right? It's like there's a lot of like little small things that you have to constantly consider. It's just like a little bit annoying, but that's the point of the exercise. Okay, so it does not compile. It's going to be 58, and stack. I don't understand what you're talking about. So we have a kind. Okay, missing at. I see. Okay, I see what's going on here. Cool. Everything seems to be working. Now, so what's the proof of solution? I forgot. It's what's the total syntax error score for those errors? Okay, so let me see. So we read the line, and I need to keep track of the like final result, the answer. Answer is going to be 0, and this one is going to be something like we don't even need to do that. And answer plus equal line score, and I just provide the line, and that should be fine, hopefully. And if I try to do that, unused variable a in line score, so we don't need this thing anymore. And I never print that variable, so let's actually quickly do that. Part 1 d answer, right, so if I try to do that, it's 30, which is not correct. Why the fuck it is 30? And what the hell is going on in here? Answer something, I don't know. Okay, so it says 30, which is obviously not correct. The fuck? Holy shit. Okay. This is definitely not 30. Let me see. We might as well just print all of the lines and their line scores. This is one of the things we can do. Right, so let's just print the line. Print SV, I provide the line. Then we can put something like this, and then its score, line score of that specific line. Okay, and for all of them it says 3, which doesn't really make much sense, right? Which doesn't really make much sense, because we only do that when, oh, well, no. So stack is empty, or on the top of the stack we have a kind that is not equal to what we put in there. Right, and only in that case we return the char score. Which is rather strange, so it's not particularly clear what the fuck is going on. It is not particularly clear. Oh, I see, because TempleOS fucked me in the ass yet again. Why don't you check that? Terry, why you thought it is a good idea not to put a check in this specific case? You do a lot of different weird checks that are not important. Why don't you check this kind of stuff? I'm actually disappointed. I'm really, really freaking disappointed. Okay, and so that now it is 0. Right, and the whole thing in here is basically 0, right? So here it's kind of weird, like part 1 is 0, and because I actually never did anything in here, so we have to at least try to do that. Answer plus equal line score. Right, so this is going to be the line, and I might as well just do this kind of thing. And it's 26397, 26397. Yes, it is. It does seem to be looking correct more. What the hell is going on? What the fuck is this thing? What the hell is everything? Terry, what the fuck is going on? I don't know, it's just like stopped working. That's the challenge. That's the challenge, I suppose. Thank you, Terry. Very cool. Okay, so I hope I didn't lose too much information. Okay, so the next thing, is to try to do that on the actual input, right? So let's go ahead and do that. So on the actual input, it's kind of sus because it looks pretty small. One of the things I want to try to do on the actual input, can we just like see what are the values, right? So let's actually have a score in here, right? And then I'm gonna do something like score, line score, line. This is not what I wanted, right? And if score is greater than 0, right? If score is greater than 0, we're going to also print that, right? So it's going to be something like this. Print SV, because it looks like there's not that many corrupt lines in there, and I just want to see them. I just want to see them super quick. So here is the score, and on top of that, answer is going to be just plus score. And let's remove this entire thing. And let me see. So there's still a lot of them. Right, there's still a lot of them, but yeah, we can see all of them. Though, yeah, it's fine. I don't think it actually gave me any useful information, so I don't know what I expected. Okay, so let's try to put that thing in here. I hope I didn't fuck it up. I really hope, because I'm already a little bit tired, so I might actually as well miss something. Okay, let's go ahead and do that. So it's gonna be 265, 265, 520, 527, 265, 265, 527. Submit that, and boom. How about that? How about that? That was harder than I expected. All right. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. So the next one, the next part, I'm gonna try to predict what's gonna be the next part about. It's gonna be about restoring the incomplete things, right? So how much you're gonna bet that it is true? It doesn't matter. I don't like to do bets. Okay, now discard the corrupted lines. Of course, the remaining lines are incomplete. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. Okay, let me guess. You have to take the missing characters and then take their scores and use them in the proof of solution. Right, it's going to be the same scores or something like that. Okay, to repair the navigation system, you just need to figure out the sequence of closing characters that complete all open checks in the line. You can only use closed characters like this, and you must add them in the correct order so that only legal pairs are formed and all chunks end up closed. In the example above, there is 5 incomplete lines. Okay, that's cool. Did you know that in autocomplete tools also have contests? It is true. Okay, so it's a different scoring. All right. The score is determined by considering the completion string character by character. Start with a total score 0, then for each character multiply the total score by 5, and then increase the total score by the point value given for the character in the following table. I don't fucking understand what you're talking about. I'm sorry. Start with the total score 0, then for each character multiply the total score by 5, and then increase the total score by the point value given the character in the following table. Okay, so this is the real challenge, by the way. So the real challenge starts somewhere here, right? Trying to fucking comprehend what the fuck is this shit. So the last completion string above is this, would be scored as follows. Start with total 0. Multiply the total score by 5 to get 0. Then add the value of 2 to get a new total score of 2. Multiply that. Okay, so you do that on each step, you multiply it by 5. I see. The 5 lines completion string have total score as follows. Okay, total points. Cool. Autocomplete tools are an odd bunch. I don't understand. I don't speak English. I don't understand these idioms. I'm sorry. The winner is found by sorting all of the scores and then taking the middle score. That's a freaking complicated proof of solution, don't you think? Like, I think the proof of solution here is a little bit overcomplicated, right? So, because the problem here is just to close them all. But then to prove that you managed to do that, you have to do a bunch of additional exercises for no fucking reason. Thank you so much. Okay, there's always be an odd number of scores to consider. In this example, the middle score is this one, because there is the same number of scores, smaller than larger it. Find the completion string for each incomplete line, score the completion strings, and sort the scores. What is the middle score? Well, to be fair, otherwise it would be too easy. Well, again, this is my problem with AoC. It's artificial complexity, artificial difficulty, not complexity. I'm sorry, I'm Russian. In Russian language, there is no difference between complexity and difficulty. We literally use the same word to describe both of the things. And as far as I know, in all of the Slavic languages as well, like in majority of Slavic languages, we don't distinguish between difficulty and complexity. So that's why I, confuse them. So yeah, it's just artificial difficulty. To be fair, it's also artificial complexity, so it just doesn't make the problem better. Just making the problem more difficult doesn't make it better. I keep comparing that to game design, right? Because essentially you're designing a game, so it is super easy to make a difficult game, right? But it's difficult to make a fun game, right? So, but just by making it more difficult, you don't make it more like challenging or anything like that. It's just like making the player to go through additional chores, and it's just like, okay, sure, whatever. Anyways, so let me see. Let's go ahead and implement that. How can I? Oh boy, so let's actually go to our repo, and I want to do a committee. So it's going to be sync. I'm going to sync into the host AoC in HolyC. Holy fucking C, what the fuck? Add home, right, status, git commit, and add day 10 part 2. Okay, git push origin master. All right, so AoC. So what are we doing here? I suppose this is pretty much the same thing, right? So I can copy paste this entire stuff. Let's copy paste this thing. So line score. To be fair, now we kind of need like a different thing, right? So we need a different thing. So this is like it's a corrupted line score, right? So let's rename them. Char score, corrupted char score. Right, and of course replace this entire thing, and replace. So another one is going to be line score, right? Line score. Can I do Control Y? Oh. Nice UI, Terry. Very cool. So line score. I mean, it's almost like in Emacs, right? So in Emacs you also, well, in Emacs there is like a attribute to the text which says you cannot delete it, right? But Templars doesn't have that. Line score, corrupted line score, right? So it's gonna be that, replace, replace. Cool. So we need to have like a similar thing, but this one is going to be not corrupted line score, but rather incomplete line score, right? Something like that. Okay, so I'm gonna quick paste it, like put it in here. Let's put it like that. Incomplete. Incompleta. So, all right. So incomplete line score. So in case of something being corrupted in here, if something is being corrupted, we immediately just return 0, I suppose, right? So we just return 0 in here. Otherwise, then we look if the thing is incomplete. So we need to do something like if stack CNT is greater than 0, right? If it's greater, well, yeah, greater than 0. This is where we'll have to unwind. Yikes! This is where we'll have to unwind the stack. Right. This is where we have to unwind the stack. So should be relatively straightforward. Like start with this thing. Okay, go. Oh, so we already have a kind of these things, and essentially the point, this one, is kind plus one, because open parent is yeah, okay. It's actually pretty cool. It's actually pretty cool. So we need to maybe put something like I64 result, and this is going to be 0. Oh, that's actually pretty cool. I can just return result like this. Look at that. So if the stack is equal to 0, it's going to just return result equal to 0. So that's fine. That's pretty cool. That's a divine intellect. This is a divine intellect. All right. So, and okay, while I have an even better idea. I was about to do while stack CNT equal to 0, but then I remembered that if is basically a while loop that has only one single iteration, but we basically need a while loop with several iterations, so we can do something like this. So that's pretty cool. Okay, so here what we need to do. We need to do result, and we need to multiply result by 5 as instructed. Right, so then we add value of this thing. So we do result plus, so it's going to be like a stack CNT, but we need to do something like this. And the kind is basically, if you add 1 to the kind, you get the point, right? And that is it, isn't it? I think it is. All right, that's cool. That is it, actually. Yeah, that's the entire thing, I think. All right, so that's pretty cool. So now, so I would actually want to uncomment the part 2. So incomplete line score. Let's start with incomplete line score. Incomplete line score. So in this case, if the line corrupted is going to be 0, we're going to ignore that thing. If the line is complete, it's also going to be 0, we can ignore that thing. So that means we need to do something like if score is greater than 0, we need to append it to all of the scores, right? So we need additional array, then we'll have to sort it and stuff like that. So the question is, like, how big of an array do we need? So we have, this is 100 lines. Okay, so that's fine. So I need to come up with a name for that array. Score the completion. I64 scores, and we can have something like scores capacity. And just in case, I'm gonna make the scores capacity 1024, right? So, and here we're gonna have I64 scores CNT. Okay, so here we're gonna have scores CNT equal 0. There we go. So if score is greater than 0, what do I do? I do scores CNT++ equals score. There we go. But I don't have to do this thing, and I probably don't need the answer in this particular case, right? So I don't need the answer. All right. So after that, we need to sort the scores. Okay. Q sort I64. Right. So scores. We need also scores CNT and some sort of like a I64 comparison function. Do we have something like CMP? No, we don't. Here's an interesting thing. Every time Terry uses Q sort I64, does he create like comparison function from scratch himself? So this is a very cool question. So let me actually try to check that. It's actually relatively easy to check. We're gonna go into the root of the drive, and there's a function called find, and it just basically recursively searches in like everywhere. So let's actually search for Q sort I64. So that will search for all of the usages of that function, and we're gonna just pick one. Right, so that's fine. So here is one of those things. Looks like it is true. Right, so every time he needs to use this thing, so there's the rep compare. Oh, maybe it's not called CMP, it's probably called compare. How about that? So compare, no, it doesn't exist. I64 compare. Okay, so apparently you have to create it from scratch. So he doesn't even use that function very often in the entire code base of TempleOS, right? Because if you go into the root drive, right, and find something, you're basically searching through the entire source code of the TempleOS, right? So there's nothing hidden, and which makes it super cool, super educational, right? So we can just check out how that particular function is used within TempleOS itself. So that's particularly cool. Anyway. So let's go ahead and go here. Just want you to check. So I64 Score Compare, right? I64A, I64B, and I think, to be fair, it doesn't really matter in which order we sort in everything because we're taking the middle element anyway. So it's gonna be A minus B. Right, so in this one is going to be Score Compare. Score Compare. One other thing I want to check, though. What is the size of the score CNT? Because they promised that it's going to be odd. Right, so let's see if they are correct. Max, just a second. So, and let me set the input to the sample, right? So we're doing the samples. All right, so let me see. So there's 5 of them, which is true. Okay, and if I take a look at the input, there is 45 of them, which is totally correct. Okay, so but let's go back to this thing. So how we're gonna do all of that? So I need to do scores CNT divided by 2, right? So this is divided by 2, but it's gonna be like -1, so we probably want to do like +1 in this case. All right, and this is the answer. This is essentially the answer, and this is the part 2, electric boogaloo. Okay, so this is the sample, and if we take a look at the sample, is that the correct one? It is not correct one. Yay! It is not correct one. Though it is one of those things, right? And the middle score is that one. So I think I did a fucky wacky and possibly an oopsie doopsie. So to test, to basically troubleshoot all of that, let's actually print everything. So I'm gonna do the following thing. I just want to see how it sorted all of them. I'm gonna start from here, scores CNT ++ I, and let's just print all of them, right? So it's gonna be something like this, scores I, and there we go. So this is that, and it has to be correct, right? If you look at that, has to be correct, but it's chosen, so maybe it doesn't have to be +1. I can clearly see that it doesn't have to be +1, right? So, I see what's going on here, because this is 0. I didn't take into account the, like, how it's counted. 0, 1, 2, 3, 4, and that's why it has to be -1. So just divide it by 2, and you get the thing that you wanted in your life, right? So let's actually confirm, unused variable I. Terry, like, why would you fucking care? You don't even have... Don't you dare tell me that I have unused variable unless you have a static type checking. Don't you even dare tell me that, alright? 288957, okay. So let's actually go into the input, right? So, and let's take a look. So that's a pretty huge ass input, so I might as well maybe like copy paste it into some sort of output, right? Right, so I'm gonna copy paste this thing and let's do ed output txt, right? So I'm gonna copy paste this thing in here, and I'm gonna save it and quit it. So let me mount this thing, AoC. All right, vim mnt home AoC 10 output txt. Alright, so I'm gonna grab this thing and I'm gonna put it in here, and hopefully, finger crossed, it's going to be BAM! First try, mother flipper! I'm sorry. Alright, that's cool. We did it! We actually did it! 10 days of AoC in holy freaking C! So let's actually do a little bit of a committee and maybe push. Okay, so run AoC 2021. Cool. So AoC 2021, and it's gonna be 10. So essentially I just want to like uncomment both of these things because I like to print both of the problems. Part 1, part 2, everything is correct. That is very pogue. Alright, so I'm going to just do the following thing. I'm going to do sync into the hose AoC 2021. There we go. Git status, git add home, git commit, add day 10 part 2, git push origin master. Cool. So you can find the source code of my AoC in here in the GitLab in the description if you're watching on YouTube, or if you're watching live on Twitch, I'm gonna copy paste it in the chat, so you can find it in here. So yeah, that was basically AoC in HolyC day 10. How about that? Isn't that cool?